Okay, so we left off yesterday talking about reverse current cutout. That's what we're kind of talking about. The last thing I said is the voltage coil and the current coil are wound onto the same core. One's in parallel and one is in series. The one in series is big or small? Big, because it carries the whole load of the generator, and the one that's in parallel is small because it just carries a little bit of current. And we talked about the fact that what happens is as the generator starts producing, the current would flow this way and down, around, and through here, except it's open. So how much current now flows through A positive?
Zero.
Nearly zero, but it will flow a little bit through here. Just a little bit of voltage and a little bit of current flow through here, which creates an electromagnet, which pulls the points down, which causes current to now start flowing this way. And that creates an even stronger magnet. And really pulls it down. So first you've got this little tiny coil that just kind of pulls down a little bit, right? Then the big current starts to flow, and the big current starts to flow, you get more magnet. Get the big magnet. All right, and that's all fine and well. So it's flowing in such a way that it's pulling these things down hard. And there it goes. And then something happens to cause the generator to not produce enough voltage that the battery is more, such as you pull the throttle back. It's all it takes in a generator because the coming in speed is relatively high. I'm going to say 1200 RPM, usually most planes what I see, 1200. So you pull the airplane back to idle like you're going to land or something. Now the generator voltage, because it's spinning slower, is less than the battery voltage. And if we didn't do something about that, the battery would start driving the generator, make the generator motor, and then that just wears out things and it's not good. So, but what does happen is the current starts to flow backwards, just like I said, because now the generator is lower voltage than the battery, so it's going to go from the high voltage to the low voltage. So imagine, you will, the generator's 6 volts and the battery's 12 volts. Which way's the voltage going to go? Backwards. So it does. Starts running through here backwards. Now, as it runs through there backwards, a minute ago, it was going this way from this point right here up, and it created a magnet that pulled the points down. Now the current runs the other way, and because of the left-hand rule of thumb and magnetism and all that, goes the other way, and now it repels the points. It shoots them open. So one way it sucks them down, the other way it shoots them open. So current starts to run backwards, shoots them open. All of the current right here now dies. The spring holds the points open because they're normally open. And the battery will run the aircraft but not make this motor, the generator motor. So all right, so you're coming into land. That's all fine and well. You touch and go. You do a missed approach, do something. Add the throttle. What happens? Generator starts spinning up again. Generator spins up. You're cutting the lines of flux even more. It starts to come back online. It senses that you've got more battery voltage, more voltage here than the battery, pulls the points back down, current starts to flow this way, brings the points back down, and bam, you're off running again. It's so simple. All right, so that's what's going. So where was I left off? Voltage coil and current coil are wound on the same core. Subpoint, voltage coil is many turns of fine wire. Voltage coil is many turns of fine wire in parallel with generator output. You guys that are typing everything I say, how much do you sell those notes for? Current coil is a few turns of large wire in series with generator output.
Kevin used to take notes if you'd share them with us.
Who?
Kevin, remember Kevin?
Oh, yeah.
Yeah, Kevin.
The-
Sorry.
Pinky. He thought I called him Piggy one day. I'm like, no. He was wearing a pink shirt. And I said, hey, Pinky. Did you call me Piggy? Because it was a kind of a short.
Yeah.
Yeah. I'm like, no, I did not.
Husky young lad.
Yeah, he's a good guy. I like him.
He was.
Let's see, points. Points are held open by a spring. Points are held open by a spring. So that means they are normally open. Normally open. And are in series with the generator and loads. When the generator voltage is above battery voltage, above battery voltage, points close. I should say when it's above a set amount. When the set amount should be above battery voltage, because I do not believe that there's any way that this is currently sensing what the battery voltage is. It's just set at a predetermined amount that should be the battery voltage. Points close. Let me see, where was I here? Generator points close, and generator supplies current to aircraft or power aircraft. As long as current flows from the generator to the aircraft, the current coil aids the voltage coil. So as long as current flows to, or is it from generator, as long as from generator to aircraft, the current coil aids the voltage coil. Current coil aids the voltage coil. A, B, C, D, F, G. If the generator voltage falls below battery, falls below battery voltage, the battery current will flow back to the generator, This flow will counter effect. This will counter the effect of the voltage coil. Coil and open points. Let's see, points are adjusted to close at about 13.5 volts in a 12 volt system, or 26.6 in a 24 volt system. Whoosh, there we go. Tell me when you're caught up.
26.6 volts in a 24 volt system?
Yep. Five. Okay, so we got to have 4 things to control the generator. 4 things are, that we discussed. We discussed that. Got to adjust the voltage. We talked about that. Got a reverse cutout. Discussed that. Equalizing in a twin. Done that. So we got 1 left.
Current, voltage.
Okay, we done with this? I'm full. I got to erase.
26.6.
Clear. Cleared. All right. That leaves the current limiter. Current limiter. Let me see here. Let's hope that's next. Current limiter. 2-unit generator control. Current limiter circuit. Woo! All right. Current limiter circuit. Well, I think this one's relatively easy. The whole purpose of the, that says reverse current cutout. Current limiter, two reverse. Okay. So the whole purpose of a current limiter is to limit the amount of output of a generator to match its rated capacity. So if you've got a 20 amp generator and you're asking for 50 amps, it won't do it. Because if you do that and you overwork the generator, it gets hot, the solder gets melty, and then the armature spinning around flings the solder out and the wires, and then the whole thing doesn't work at all. So the idea here is to limit it to what's going on. So let's take a look at how this works here. So we've got the generator. Can't wait to see how it works myself. Got the generator, has the output, the voltage regulator, which we already talked about, going to reverse current cutouts, what's next in line, but this one's going to sit between the two. So we just have current is going to come through here. Is this going to be a fat wire or a thin wire?
Fat wire.
Very fat wire. All right, so that's going to go up like that. Contact points are normally closed. Well, that's a good thing, because if you really think about how this works, you have to come through here. There's nothing to close it, so it has to be closed. Then it's going to go off to the reverse current cutout, which is normally open or closed?
Open.
Open, and it's going to use voltage to close it. So we got a path going through here. And let me see here. We've got the field coil right here, and this is all set up going through here. See, this is off to the field. So we're going to control the field here. So what happens is, since they're normally closed, when we get enough current right here to open it up, it's just going to be an electromagnet that can open these up, break open the contact points, and what that will allow is some current to flow through the resistor, limiting it the output of the current going to the field coil, throttling back on the voltage on the generator. That was the easy one, I think. You see how that works?
No. Can you do that one more time?
I don't think I can. Okay, normally, contact points, normally closed. So in a normal situation, these are closed. I start up the generator. Output comes up through the voltage regulator. We already talked about it. Through the voltage regulator, we can just see that through the normally closed, down, around. And it says, this side at least can say, hey, I want full output as far as the current limiter. Current limiter says, I want full output. Well, voltage regulator, we've already talked about, it's going to be doing something else. It's monitoring voltage. So it's like a committee, right? It's, Harry's up here. Vin, you can be my buddy. So Vin is my voltage coil, because he's a little thinner than I am. So I'm kind of, so that makes me the current guy. So I'm current guy, and we're running at 10 amps. More current. And what does Vin say?
No.
Less voltage?
Yeah, he says, well, I don't care about you, current. I want, how much voltage you want? How much? 10? It's a 12 volt battery. You got to charge it higher than 12 volts.
Okay.
So 13.
15.
All right, he wants 14. So he wants 14 volts. What happens if he gets to 16?
He says no.
Yeah, he's maybe you're fired. I would take Tobias. He's more argumentative. So Tobias says more voltage, and he says less voltage, and he says more voltage. That sounds actually like Tobias over there. And the whole time I'm sitting here, I just want more current, man. I just want more current. I'm fine. Got plenty. I don't need it. And then if it's a 20 amp and it gets to 21 amps, boom, stop it. Got to stop right now. No more current. So what happens is the current is coming through here all the time. It's just always going through here. If it's 1 amp, 2 amp, 10 amps, whatever, it's fine. But then when it gets, and it's creating electromagnet, and it's trying to pull up on this one right here. So it's trying to pull up on it. And when I get to, say, 20 amps, and that's my limit, this is strong enough to overcome the spring and pull this up. And when it pulls it up, you got no more. I'm limiting the current. And it's going to start vibrating. It'll start vibrating and controlling how the current gets through to the field
So it's
coils.
sending more current back to the generator once it's open up?
It's always sending it off to reverse current cutout. See, it just comes out of here. All the load always goes through right here off to the reverse current cutout. But you just attach some points to the bottom of it and say, well, put a spring on it and say when the current in here is, say, 20 amps, and when it reaches 20 amps, then this electromagnet is enough to open up the contacts. And so then eliminate it. Then it goes back to 19, these will drop. Goes to 20, pops open. Something like that.
Are like the contact points rated for, like, depending on what you want? So 20 amps
Yes.
is rated to pull open at 20 amps.
Yeah, you have to match this to the right one.
And do we adjust that spring, or is that like preset?
You can. They're usually preset, and I've never had to get in there and start adjusting them. But there are little adjustments in there, but you can if it's not quite right. It's not unheard of to have to adjust voltage regulators, but usually not current regulators because you don't usually know that it's not enough. Let's see. Okay, current limiter. Same thing. It's a vibrator type. Vibrator. Could be solid state too. Designed to reduce generator output if max current is reached. Designed to reduce generator output if max current is reached. Why? Because excessive output will lead to overheating. And then overheating causes solder to fail and windings to come undone. Do I need to write that? I don't think so. It's very, geez, he just wants to. That'd be I anyway, and that'd be 1 if we do it right. Excessive output. See, overheating causes solder to fail and windings to come undone.
And that's what happened to that generator up there in the
I think so.
Sets the current.
and someone dropped it.
All right. So works just like the voltage regulator. Just like the voltage regulator. Except and the voltage regulator is wired in how? Which is wired in parallel. So the voltage regulator is in parallel. So it works just like the voltage regulator, except it is wired in series, right? Except it is wired in series. And because it's wired in series, it senses
Current.
Senses current. So when load is excessive, current is enough to open the points. Open the normally closed points. This adds resistance to the field coils, which decreases output. There we go. A lot of writing, huh? You don't have to write everything. Okay. The decreased decreased output of going to the field coils. So the decreased output, actually no, take that back. That's not where I'm going with this. So the decreased output of the generator reduces magnetic pull on the points, and they close back up. All right, so when the load is excessive, the current is enough to open the normally closed points. Boom, they open up. Adds resistance to the field coils, which then decreases the output of the generator. The output of the generator goes down now that that coil is happy again, so it has a decreased output going through the coil, which means decreased magnetic current, which means it has less effect on the points, so the points close back up. Points are closed back up. Generator starts to go again. So if the generator output is near the limit, what will the points do? There, you got it. Points vibrate. Typically speaking, points are designed to open at about 10% above a rated capacity of generator. I don't know why I threw this in here. I'll just write it.
Probably important.
I know, that's why if I don't write it, maybe it's a Q&A question or something, and I thought, well, I'll put it here. But I have fuse type, I don't know why. A high capacity fuse that will melt in the event of a prolonged overload. Fuse that will melt in the event of a prolonged overload.
Doesn't sound very efficient.
Well, you're assuming that maybe the points arc themselves close, and so you have to have some protection. So you would have some sort of meltable fuse that, and they're pretty fat, and they're not. You have to get in there with wrenches and stuff to replace it, but the fuse will melt, and then it shuts the generator off permanently. till you get to ground station and have it fixed.
So you want those to melt before like the solder melts?
Yeah.
in the generator.
Yeah, it's cheaper to replace that little fuse than it is the whole generator. And before I move on, I want to explain one thing here. I don't know where it's in my notes. Maybe it is, maybe it isn't. There are really two types of generators that you run across, and they call them type A and type B. And it's actually kind of a simplistic thing. I have to think if I can draw it correctly. We have the armature, and we have the field coils. And we'll see, oh, here we go, brushes. Brushes right there. That go here, that'd be the armature. And then we have the field right here. So if I look at my field right now, so this is armature out, and I can look at my field right here. Do I have a complete circuit on the field?
Nope.
What's missing? Okay, so it's not grounded to anything, is it? So I got an F right here. So that's the F post coming out, and there's the A post coming out. So that's all you really get on a generator. So I don't have a ground. So that is where the voltage regulator is going to go. So then I'm going to create a voltage regulator, and I'll wire this to the voltage regulator, and the voltage regulator will provide a ground. All right, so this is an A type. So in other words, it finds a ground. So if I want to turn this generator on full blast, what do I do?
Straight to the ground.
Straight to ground. I run this wire right back to there. It will turn on all of the way with zero regulation. You'll just watch every needle go wham. What will voltage do? How much voltage will you get? All of the voltage. How many amps will you get? All of the amps. It will just go until it can't go no more. And when you do this, I'll show you when you guys run your generator. I'll do it for a split second. The entire motor bogs that's running the generator, it bogs down. It's a huge load. Whoa, and you watch all the needles just slam over to the right. Like, damn. You know, it just pegs it out. I forget what it goes up to, but I accidentally dropped one of the, I had the wire sitting on the F, and it fell over and it wasn't insulated and arced across and grounded itself out. I was going to tap it real quick, but it did it, and it went down. So A-type needs, field needs a ground. Field needs a ground. Or a negative, if you want to look at it that way. All right, but then the opposite of that would be the B-type. So armature, brush, that'd be the A plus out. That's also A plus right there. A plus out. And let's see. It would look more like this. With the field right there. So what is the field missing?
Positive.
Okay, it's missing a positive. It needs a positive right there. So how am I going to get it a positive? Well, you're just going to use a different type of voltage regulator. And that would go right in this spot right here, where the field would go to there and then back to there. I should have left more room for my drawing, but you just need to supply a positive to the field. So field needs a positive. And it just gets it from the armature output. It's right there. So it's already grounded. So that's A type and B type. So how would I turn this generator on full blast?
Wire it straight to the armature.
That's it. Just put a jumper wire right there. Field to armature. And how many volts do I get?
All of it.
And how many amps do I get?
All of it.
That's right. What if I decided instead of doing that, I take it and I ground out that field post? It's already grounded. It doesn't care. It's like, dummy. So how many volts would I get?
None.
Oh, that's not the right answer.
Well, whatever's in the core.
Yeah, tell me about that.
So the core has its own magnetic field. So
Core's got that magnetic core. It's got a core. The pole shoes, it's got its own magnetic core, which is just a little bit. So how many volts would I get?
just that little bit.
That's a couple of volts, 2, 3, 4 volts. So if you're ever trying to troubleshooting a generator and you test it on a bench or you're running it and you're like, man, I'm getting like 2 volts, 4 volts. What does that tell you? You're running off residual magnetism, and that's all. And so it tells you that your field coils are probably bad, or not getting any, either the A positive or the grounding on it. So you kind of keep that in mind as you're looking with these voltage regulators and that's really the voltage regulator, what it's doing. What is it trying to supply? So, all right, so that brings us to the item number 6. The 3-unit controller. And that contains the voltage regulator, the
Current regulator.
current limiter, right? Same idea. The
Reverse cutoff relay.
Yep, reverse current cutout relay. There you go. Contains all of those things. So let's take a look at one. Do I have one? I have one. How about that? From current slide. All right. So what do we got going on here?
That sound.
Okay. Oh, I got highlighter. Let's try that. That kind of works. All right, so we have, except you can't see yellow, so I can't use that. Red, all right. So we have current comes out of the armature, the A positive. It's always going to be A positive because that's the outside. Now let's see, is this an A type or a B type generator?
A,
Why is it an A type?
has
Because it has an A.
A, has A positive.
All right, well, let's see. What does this need to make it work? It's got an F plus. F plus, where's it coming off of? Here, let me see, it goes there, back around, there. Looks like it's a B type, doesn't it? And what about this end of it? Where is this going?
It's grounded.
Grounded, so this is a
B type.
B type.
Constantly grounded.
All right. Okay, so we've got current, it comes through here, current, and it's going to go to about right here, right? So we'll stop at that point right there. We'll kind of take a look at, is it going to be able to go any further? So let's see, we'll go here, down, through here, right there. I gotta, these are normally open or normally closed? Those are normally open, so let's write that down there. Pen. These are normally open. Does it say that anywhere? Liars. Doesn't matter if it's A or B. That's normally open. Why is that normally open? It's reverse current cutout. If I turn the master switch on in the aircraft and that thing's closed, I've just made a motor. I don't need a motor there. Be fine if I'm trying to start the airplane, and that's what it went to. I suppose, well, I wouldn't want that to happen when I turn on the master switch. All right, so we just determined that going all the way through these coils here, I've got to open, so it's not going to go any further than it is right there. But let's see, does it go down? And it goes through here, and we're going to get to these contacts. So these contacts normally open or normally closed. Voltage coil. Normally closed. Let's write that up here. Pin. These are normally closed. Normally open. And we have the voltage. Shouldn't let me have colors. The voltage is going to come through here. Down through here. Let me see. Got to find it back through here. Let me see. Oops. Coming through here. There, I like that better. Through here. Kind of finds its way around. It's a little bit of a complicated drawing, but there we go. There's my field, all right? So field is going great. And these are normally closed. So what happens if I'm spinning this up and voltage gets too high? So these open. Well, that's kind of fun. That opens up, and then the path of current changes. So instead of going through that there, it has to go through a resistor back around and limits it. Follow? All right, so there we go. There's my voltage sensing side. So we got another voltage sensing side. Well, in reality, we do have a little bit of current comes through here, through here. So I'm sensing some voltage over here. You can go to ground there if you want. Like how that's connected there. Runs that coil. So when this coil over here, the voltage coil, reaches about, what did I say, 13.5? 13.5 volts right there. What happens?
Closes it.
Okay, this closes up. And now, when that closes, current starts to flow through here, around, through here, and out to the aircraft. And it's going to run just like that with this set of points right here vibrating and keeping it right there at the voltage that I've set it at. And it's going to run nice and happy until what happens? You want to go reverse current? Okay. I come into land. I pull the throttle back. I pull the throttle back. What happens?
Points closed.
All right. Well, what happens is the
Current goes down.
okay, the generator slows down. The voltage drops. Voltage drops. What do these points here do?
Open.
No, it's going to close. Voltage drops. Voltage coil says, "Man, I got to have more voltage, dude." And the armored generator's going, I'm giving you all I got, Captain. And so, but it's not enough. So the voltage starts to drop, right? It's 13, 12, 11, 10. Battery's over here going, woo! Guess what I just found? A motor. Current starts flowing this way. Current starts flowing that way. It comes back through and starts to motor the generator. Draining the battery. Huge load, right? Well, you can't have that. So that is going to cause current to go the back way, which is then going to cause the magnetic force to push these open. This opens up. That kills the current all the way back. All right? So then we add more throttle. Bring the throttle back. Okay, so now the generator's back online because it sensed it right over here. Comes back through. We're going back to the aircraft. And now you decide you're going to run everything you can and plug in a coffee maker to the cigarette lighter. Cigar lighter, yes. And so we get too much current going through the current coil, which is going to react on this one. And are those normally open or normally closed? These are normally closed, but now we get enough pressure out of this to lift up on that, open it up. That opens up. And when this opens up, let's see, what do we got? Instead of flowing this way and around, it's got to flow the way I got it drawn right there. It's got to go down through that resistor and throttles back on the generator. So it starts limiting the field coil. And that limits the output, and then it doesn't blow up. Yes?
So the voltage coil is still bringing those points normally open, but bringing them closed, right? That's still happening.
Say it again?
So the voltage coil?
This one?
Yes.
Because there's two of them.
Right, so like the voltage coil,
In the voltage regulator?
yeah. No, in the reverse current relay.
Yep.
That's bringing the points down.
That barely brings them down.
Barely, like
Yep.
So it makes contact, and then the current coil comes in and makes them tighter, or
Yes.
eliminates more.
This one makes them tighter,
Okay.
locks them in.
Okay.
Until such time as the current starts to flow the wrong way, then the current coil overcomes the voltage coil, because the voltage coil is still sitting there. No, it's okay. You can close. I don't mind. We're working. But the current coil is the brains of the operation. This one says, no, it's going backwards, dude. So it pushes open the contact points here and stops the flow of reverse current. But really, this voltage coil is still going to be engaged, going, but I got voltage,
Yeah.
right? So it's going to want to bring it back down, but not until it gets back up to 13.5.
Okay. So 13.5 is key to have those points.
Yep. So it drops down to 12, then this wouldn't be enough to close it. 11, 10, back up the other way. 12, 13, 13 and a half. We're good to close. It closes, current rolls through here, locks the points back down again, and now they're nice and solid on there. And everything's happy until we get too much current. Then that lifts up this one here, but current still flows out. Never stops the current. The only thing that stops the current is these points. These points and these points right here. All they do is limit the field coils. So you got voltage coil, current coil here in the current limiter, voltage regulator. They limit the field coil. The reverse current cutout limits output or stops output. Yay?
Yeah.
Okay. Wow, look at that. Okay. Discard. Okay, that's all. I don't have any notes that I'm going to write over all of that because it would just be repeating what I just did, because what we did is we covered the voltage regulator, then we covered the current limiter, then we covered the reverse current cutout. Then I put it all together and I showed you how it worked there. So your job then is to be able to look at something like this, which you will, and tell me how it works. You're like, wait, you should have said that first.
Yeah, repeat what you.
Wait, say everything you just said again. Yeah. Which I will,
Awesome.
without color, unless you need me to. Okay.
That helps.
No, do that.
Okay.
No need to.
So we have to. Well, I'm going to make some notes on here. 10. Okay, so let's get this right. So this one here is normally
Open.
open. This one here is normally closed, and this one is. Is it normally closed? Okay. Okay, so normally closed, normally closed. This is what type of generator? A or B type? It's a B type because field needs positive. That's the B type. Okay. So we got normally open. Okay, got that going. That looks good. Back to this, you can see it. All right. So current, just all on its own, has got somewhere to go right now. You start up the aircraft, you hit the battery switch, turn on the engine, generator's spinning, right? But not real fast. So we've got current is going to be coming out of here. Why is there current coming out of here? Because we have a couple of volts off of the field not coils, the field poles that have some residual magnetism, which starts the generator working. All right, so it's going to come through. The fat wire means it's in series, comes around and has nowhere to go except a little bit down here, wanting to sense about, how much volts?
13.5.
Okay, we'll say that. So at about 13.5 volts, this is going to close. But if we haven't reached that yet, we're at 12. What is the voltage coil saying? Need more, right? It wants more. So is it going to give it more? Yes, we have some current will come down through here. These are normally closed. So if they're normally closed, let me see, there's got to be a direct path. Normally closed. Normally closed. There's a path right there. Direct. I didn't hit a single resistor right there. See that? Okay. This way. Normally closed. Right there. I said I wasn't going to draw on it. There we go. There. Straight path. No resistance. This thing's turning. It's asking for all it can get. got to give me some voltage. And so got to get some voltage. All right, so you get the engine spinning fast enough now that you hit the coming in speed of the alternator. Once you hit the coming in speed, that means it's capable of producing the amount of voltage that it needs to operate the aircraft above battery voltage. So it reaches above battery voltage. Well, what's going to happen here? The voltage coil is going to start pulling open on these points a little bit, opening them up. We're going to go through some resistors, start limiting the amount of current going through the field windings to vibrate, to limit it and hold it at the proper voltage. Yep. Meanwhile, this coil here sensed that we're above battery voltage, or at 13.5. It closed these. That allows current to flow through and out and off to the aircraft. And that it will do until either we pull back on the throttle and the generator drops below the coming in speed, at which point current comes backwards through the coil and pushes these open. And they'll stay open until this coil here reaches 13.5. Or we exceed the current here, which will simply pull on these points and limit the amount of current going through the field, which just throttles back. So voltage coil here, it's a throttle. Current coil here, it's a throttle. Current coil here, shut down, opens up. You get nothing. Good?
Yes.
Okay. Oh, do it 3 more times. All right, that is break time.